Okay. For this picture, there are two words in it. One is called IGP. One is called EGP. That is an internal gateway. External gateway. The internal gateway is used in the local area network. That is LAN. Remember the LAN of the local area network we talked about in the first class? Exterior gateway routing protocol used in wide area networks. That is WAN. Their application scenarios are different. So how to distinguish them? This LAN and WAN are too abstract. IGP is called Interior Gateway Routing Protocol. EGP is called Exterior Gateway Routing Protocol. How to distinguish between the inside and the outside? We talked about something before. AS. That is autonomous system. I said it before. Within an AS, run the same dynamic routing protocol. The strategy is relatively simple. Is a network built by a unified manager, called AS. So what we call external and internal refers to an autonomous system, external and internal. Like a door. The outside of the door and the inside of the door are called inside and outside. Inside and outside of this agreement refers to the autonomous system. Then the interior gateway protocol refers to the protocol running inside the AS is called the IGP protocol. Exterior gateway protocol refers to the protocol running between AS is called EGP protocol. Then the typical EGP protocol running between AS. The BGP protocol currently used in the WAN. You will learn in the NP course in the future. There are many interior gateway routing protocols running inside the AS. OSPF, ISIS, RIP, EIGRP, etc. If you don't know Cisco before, I can tell you about EIGRP. Early on it actually belonged to both the interior and exterior. That is, it can actually also be used between AS. But unfortunately, it launched and opened too late. Now all the ASs on the public network are running BGP. EIGRP as a whole was born late. That is, appearing late. We will learn the configuration of EIGRP later. You will find EIGRP also needs to configure the AS number. So if some students know BGP, you will feel very kind. Because only the public network, that is, the AS number is only required between ASs. So you come across a protocol. The AS autonomous system number needs to be specified. Means that it can run between autonomous systems. It is not a pure interior gateway routing protocol. For EIGRP. First, it was launched relatively late. Second, it opens relatively late. That is, it can run both in AS, can also run between AS, and want to compete with BGP. But unfortunately, when it's launched and it's open to the market as a whole, the market has long been occupied by BGP. So EIGRP is sorry. Many functions have been developed, but in the end it was not put into use. EIGRP itself has a very good protocol mechanism. Just make it easy for everyone to understand. Will be covered later in the advanced course. AS internally called IGP. Between AS is called EGP. This is the difference between their names. Including AS itself is also a concept in BGP. It's better to take it out. Some students may ask, does internal mean the kind that does not include operators? In order to facilitate your understanding, I will draw another picture. For example, this is operator A. This is carrier B. This is the company. There are many routers in the company. Of course, between operators is also a router. But I won't draw. I'll just draw it. This is the device we're talking about. Future. The company may have business interconnection with the operator. First of all, let's talk about where these things are running. The IGP protocol will run within the company. Whether it is IGP, OSPF, or EIGRP, running between these devices. If the company is relatively large, need to do some information docking with the operator. A company is an AS. Is a private AS. Also numbered. The operator is a public AS. It also has an AS number. BGP is now running between the two ASs. Although now, only BGP is used in EGP. Then between operator A and operator B. They run on the public network. It also runs the EGP protocol. So we can also know the difference between them. Of course, the IGP runs among them. Because operators are now using ISIS of IGP protocol. OSPF they are not used. This is the usage scenario of various routing protocols. I made a distinction for you. Then when you come into contact with ISIS in the future, it is necessary to learn to be biased towards the direction of the operator. You will only touch this. Cisco doesn't seem to talk about it. Sometimes I will take it out and say it simply. But don't say much about it. Because it is not part of the routing switch. In the enterprise network, you must first understand. Within an autonomous system, we all use IGP. Carrier A is also an autonomous system. Of course. Carrier A between various distributions. They are also different. The autonomous system also runs IGP. It is also EGP when docking. It's all the same. Okay. Next. What we're going to talk about is EIGRP. That is the first dynamic routing protocol we touched throughout the NA phase. Same. Let's talk about a distance vector routing protocol and a link state routing protocol. Let's first look at the content of EIGRP. I just introduced to you. It is also an IGP protocol. Interior Gateway Routing Protocol. Also used inside an AS. It was previously a Cisco proprietary protocol. But now it's publicized. Need money. So, we often still treat EIGRP as Cisco's proprietary protocol. Because very few people actually use it. Unless it's still a pure Cisco environment. Otherwise it's hard to see. And in EIGRP, it will have its own algorithm. This algorithm is called the diffusion correction algorithm. That is dual. Also known as diffuse update. Well, I just told you. Like SPF. It is the algorithm used by OSPF and ISIS. Dual is the algorithm used in EIGRP. We will also talk about the specific content of this algorithm today, including how to judge distance vector routing protocol and link state routing protocols. Depends on what it interacts with. Because EIGRP interacts with the routing table. So we call it a distance vector routing protocol. But it combines link state. Usually. It also has link state features. But it's essentially a distance vector protocol. Okay. We will learn it formally next. There is a sentence in it. I need to give you an explanation. Here you can see. It supports many network layer protocols.